Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today we have an interview with Jack Horner, which we're really excited about, and a discussion about Maiasaura peeblesaurum, as well as a lot of dinosaur news. So first in the news, there's a story from gotscience.org by David Hone, and he describes a giraffe titan that's in the Museum for Nature in Berlin. It has been installed there since the 1930s, but then it was disassembled, cleaned, repaired, and remounted back in 2007. Back when it was originally mounted, they pierced many of the bones with metal rods in order to hold it up, and that allowed them to mount it in a way that looked a little bit more, realistic, I guess, even though you'd never see a dinosaur's bones like that. But it, wasn't covered in metal. It was a little more hidden. But obviously that's not the best way to preserve fossils, drilling a bunch of holes in it. So when they put it back up, they built a complete metal framework around it, and they used that basically to hang the bones off of it rather than pierce them. So there's a lot of wrapping metal around it. You see more metal, but obviously better for the fossils. The new style also allows them to easily remove individual bones for research or cleaning. And while they had all the bones out, they took the opportunity to digitally scan key bones for research. We've talked some about those 3D models that they have. The article also goes into some details about different fossils, quote-unquote fossils, that you might see in a typical mounted dinosaur. Because complete fossilized skeletons are very rare, they have to do some interesting things to finish the skeleton. There's basically three main things that the author points out you can do. You can take a fossil from a similar specimen of a similar size and just put it right in there. You can copy a bone from another specimen or a similar bone in the same fossil, like a rib, for instance. Most of the ribs are pretty similar, so you might be able to just copy one over. And then finally, you can sculpt a best guess of what is known about that specimen and just kind of come up with a bone. And they have to do that quite a bit, actually, because especially in new species, they might know some relatives, they might have an idea of what it looks like, but they need to scale it, so you have to actually build the thing. David also mentions that museums highlight on occasion which bones are real fossils and which are replicas or other reproductions, but many don't do that. If you're interested, he points out a couple things you can do to tell if it's a real or a fake. You can look at different colors in the fossils. A lot of times the fake fossils or the casts or the replicas or whatever you want to call them will have a more consistent color, and in the real fossils they might have to fill in gaps, and that leads to inconsistent color, as well as other sedimentary processes. Getting different chemicals can change the color a little bit. You can also tell differences in the texture, especially if it's sculpted, because sculpted fossils tend to be a lot more smooth than the rough texture that you get on an actual fossil. But at the end of the day, it's important to remember that almost every dinosaur skeleton has at least one replica bone in it, so it's not really anything to be disappointed in. It's just kind of fun to look at them and try to find which fossils were original and which weren't. The next news story comes from the Cambridge Network. On their website, they talk about an interesting old song that's related to dinosaurs. A little bit of brief background. There was this place called the Crystal Palace, which was built for the original World's Fair in England. And like a usual World's Fair, it had tons of spectacular exhibits, and a giant iguanodon model was a big piece of it.
Yeah, it was because of Sir Richard Owen who coined the term dinosaur. We talked a little bit about that in previous episodes.
So while they were making the giant iguanodon model, a group of entrepreneurs who were involved in the World's Fair in 1853 dined inside the mold of the giant iguanodon, and they were reported to sing a song about dinosaurs. And I found some of the lyrics to that song, so I want to share those. We don't know how it was sung because it's just written down, but the song goes something like, 1,000 ages underground, his skeleton had lain, but his body's big and round, and there's life in him again. The jolly old beast is not deceased, there's life in him again. Roar! I'm assuming they actually roared because they're probably drunk. So that mold would be one of the ones that they used to create the world's first full-size set of dinosaur sculptures. And like Sabrina mentioned, it kind of brought dinosaurs to the forefront of a lot of people's minds. Next in the news is a place called Urinhat. I think I'm saying this right. It's an area between China and Mongolia where several dinosaurs have been discovered lately. And because of that, it drew our attention to this awesome dinosaur arch that they have there. So this arch consists of two huge sauropod sculptures that are quote-unquote kissing over a road. And their necks serve to make an arch over the road, which reaches a height of 19 meters or 62 feet at the highest. And when you combine the length of the two sauropods facing each other, it's a total of 80 meters or 262 feet in length. So it's pretty huge. They're located in the Gobi Desert in Inner Mongolia, and that area has attracted the attention of paleontologists since the 1920s when the first dinosaur was discovered there. And despite the arch being built in 2007, the dinosaurs look a little bit 20s era with their tails dragging on the ground and, some other things that if you look at them you're going to say, doesn't really look like a dinosaur.
But it's still cute.
Yeah, they're still pretty cool. Urinhat is sometimes called Dinosaur City, and there's a nearby dinosaur museum as well as a theme park called Dinosaur Fairyland. I saw some pictures of a bunch of sculptures they have around, including a T-Rex inside an egg, but with a little cutaway thing that looked really cute. It looks like a pretty neat place to visit. Apparently they get a lot of visitors in that area, despite it being a little bit out of the way. Next in the news is a prehistoric forest. And if you read that article, you probably thought it was a real forest. But actually, it's a 10-acre property that's for sale in Ohio in the U.S., and it has a minimum published bid of $275,000. But what makes this property interesting, to us at least, is that it has a set of full-sized hand-painted dinosaur sculptures, as well as a fake volcano. And the most recent owner purchased it as a tourist attraction in 1995, even though it's been open much longer than that. But in 2010, the owners decided to close the park, and then they decided to put it up for sale just recently. So nobody's really sure what's going to happen with the park after it's sold, but hopefully someone will reopen it. It sounds like a pretty neat thing. Next in the news is the Connecticut Science Center in the United States. They've remodeled their quote-unquote extreme dinosaurs exhibit, and from what I can see, they have added some more animatronics, and the dinosaurs look like they're now colorful and covered in feathers, which is always a good start. According to their website, it'll be around for at least 2015 and includes 22 animatronic dinosaurs, 16 fossils, some dinosaur skeletons, and interactive activities. The only interactive activity I saw on their website was this thing where you stand in between a bunch of cameras and it takes a picture of you. It doesn't really have anything to do with dinosaurs. I don't know why it's in the exhibit, but it is. The example they did was a bunch of people jump up in the air and then it shows all the way around, kind of like a model.
Maybe they put dinosaurs in the background of the picture.
Yeah, it could be. Next in the news, there are 3 different museums in Las Vegas, Nevada in the U.S. that are currently housing big dinosaur exhibits. They're partnered together and have complementary exhibits rather than showing the same thing or similar things in each museum. And Aaron Mikulev, curator of the Springs Preserve, said that it could have been a situation that didn't work out well, and it would have been like several girls showing up to the prom with the same dress on. So they decided to all work together to make complementary exhibits, and since all 3 museums are nonprofits, there wasn't a big kerfuffle about who got to show what, I guess. So the 3 museums that are involved are the Discovery Children's Museum, which is displaying Dinosaurs Land of Fire and Ice through September 13th, and it includes the different habitats that dinosaurs lived in, and has an ice slide and ice cave with tunnels for kids to crawl through. There's also the Springs Preserve that's displaying something called Dino Summer through September 20th, and that one includes animatronic dinosaurs and, quote, arcade-style video game systems where visitors can drive a virtual dinosaur avoid predators, or look for prey or food. And the last one is the Las Vegas Natural History Museum, which is displaying, quote, Dinosaur Revolution through September 15th. This one sounds to me like the most interesting one. It's got a trivia maze where you use your dinosaur knowledge to avoid dead ends, and then there's an exhibit where you can look at evidence and determine whether T-Rex was a carnivore or scavenger, as well as a mini zip line and a dig site and a rock wall for kids to climb on. And they're all closing in September, like I mentioned, and next year they're not going to have anything even remotely like this. They say that their varied plans include an exhibit about Clifford the Big Red Dog, ancient Rome, and then the last museum has an exhibit on the physics of light. So if you want to see dinosaurs, you kind of have to go this year. All right, so we've talked about Ark Survival Evolved in the past, the game that's still in early testing, but you can download on Steam. And a modder named Spartan 464748 took the time to recreate the second and fourth levels of Halo inside the new Ark game. So I watched a bunch of video about these levels, and the maps look really good. They look a lot like how Halo looked in the original game. Obviously, higher resolution since Halo came out back in 2001. So there's been quite a bit of new technology since then. And watching somebody play through it reminded me of a Turok-style game where there's lots of guns and dinosaurs and all that kind of stuff. But if you're into Halo, it's a pretty cool combination. And both of the levels are available in the Steam Workshop, where you can download them. And since Sabrina and I just got to 100% in LEGO Jurassic World, we might have to check this one out now. This is going to sound crazy, because Jurassic World is still in theaters, but there is already news coming out that there's going to be a sequel, which is probably because it's grossed $1.5 billion worldwide, making it the third biggest movie of all time after Titanic and Avatar. Universal even announced when the sequel would come out, saying June 2018, and one source even had the specific date in June. It just seems crazy for a movie that's supposedly going to come out 3 years from now they don't even have a script for. But the sequel will feature both of the main Jurassic World stars, Chris Pratt and Bryce Dallas Howard, and it will be executive produced by Steven Spielberg, and it's actually going to be written by the Jurassic World director Colin Trevorrow. We've mentioned before that Jurassic World was intentionally a bit of a setup for future movies, but I didn't notice this little nugget that Trevorrow mentioned in an interview with Wired. He said, quote, Dr. Wu says in the film, when he's warning Dr. Masrani, we're not always going to be the only ones who can make a dinosaur. And he says, I think that's an interesting idea. Even if we don't explore fully in this film, there is room for the universe to expand. I shouldn't use the word universe, because then people are going to think we're making Jurassic World universe, and we're not. But I think that is an awesome idea. So he wants to see competing dinosaur manufacturers making different dinosaurs and what kind of antics would ensue. And he doesn't want it to be on an island either, because he thinks there's been too much island stuff going on. And my favorite part of the original trilogy might be when the T-Rex was in San Diego. That part was super cool. So the idea of the dinosaurs being back in cities and urban environments sounds like a really cool idea. 2018 June, here we come.
June 22nd, to be exact.
Yeah.
And last in the news, Comics Alliance published a 10 dinosaur comics list, I think because of the trends with Jurassic World and people starting to realize their love of dinosaurs. They're not all new comics. Some of them are ongoing, some of them are also from the past. So just to list a couple examples, we've got Cadillacs and Dinosaurs.
I think that one's my favorite. It's got a picture of a Cadillac driving, and then people, what are they, shooting at the dinosaur?
Yes. Devil Dinosaur. Dinosaur Comics, which I've actually seen online a few times, and it usually features this one green T-Rex saying a lot of things and doing a lot of things. Dinosaurs Attack, Ninjasaur, which we have talked about.
Yeah, we talked about it in an earlier episode. I think there was a Kickstarter.
Super Dinosaur, which is a dinosaur suited up in, looks like he's got rockets.
Is that the one with the T-Rex holding little joysticks for his huge arms?
Yes.
Yeah.
Turok and Tyrant, Age of Reptiles and Paleo. Oh, as well as The War That Time Forgot and Warlord. We'll post the link on our blog later this week, and you can also see they have a bonus Jurassic World fan art gallery.
Some of those pictures are actually really good.
And that wraps up the news. Jack Horner is the curator of paleontology at the Museum of the Rockies, the Regent's professor of paleontology, adjunct curator of the National Museum of Natural History, and he teaches the honors program at Montana State University. He's also the inspiration for the character Dr. Alan Grant in the original Jurassic Park. And his first big discovery was in the 1970s of a nesting site for the dinosaur Maiasaura, which means good mother lizard, and we'll get more into that dinosaur later. But since then, he's named several other dinosaur species, including Orodromeus, and he even has 2 dinosaurs named after him. He is also credited with discovering one of the largest T-Rexes known, even larger than the famous T-Rex named Sue, and his research includes dinosaur evolution and ecology, emphasizing growth and behavior. He's written 8 books about dinosaurs, including a children's book, as well as over 100 professional papers and numerous articles, and he's also given some TED Talks about dinosaurs. So without further ado, here's our interview. Garrett and I are really big fans, and we've seen your TED Talks, and how did you get involved in Jurassic Park and become the inspiration for the character Dr. Alan Grant?
Well, the inspiration thing, that was Michael Crichton. When I met him, he claimed he had read my first book, Digging Dinosaurs, and based the character around myself. And he apparently had also read Bob Bucker's book on dinosaur heresies, and he took some of the character from Bob as well. And then when Steven Spielberg made the movie, he decided to just use my character. Who knows? Well, I'm just glad I'm glad the character didn't get eaten.
Yeah.
That's true.
But working on the movie, I just got a call one day from Steven Spielberg, and he asked me if I wanted to work on Jurassic Park with him. Hard to say no.
So what was involved? What did you do in the movie?
Well, he was looking for someone who tell him, what was wrong with the dinosaurs, and also he wanted someone to work with the model makers, Stan Winston's crew and so forth, and ILM, to make sure that the dinosaurs were as accurate morphologically as they could be. But then, if he was going to make actors out of them, he was going to make them do things that they wouldn't normally do. My job really was just to make sure that, that there weren't any, really bad mistakes. And, I think we picked out most of those. But, obviously, some of the dinosaurs are bigger than they should be, and some are smaller than they ought to be, and, that's all just artistic license.
What was some of the biggest, mistakes that you had to correct?
So the biggest one was in Jurassic Park 1, when the raptors come into the kitchen, they were originally going to have them wave their forked tongues around like snakes do. And, we know that dinosaurs didn't have a Jacobson's organ. We know that they wouldn't have done that. But I was able to get that out of it, but he still needed something to happen for that short period of time. Mm-hmm. And so we decided on the scene where they come to the door and one of the raptors snorts and it bogs up the window. So basically we've taken away the reptilian look and the reptilian feel to them and given them warm-bloodedness.
I know you also worked on Jurassic World, and I read an article where you said you didn't think Indominus Rex was crazy enough. So what's something you would have liked to see in Indominus Rex?
Well, I'm not sure what you read, but I was very much involved in Indominus Rex, and it has most of the characteristics that I wanted. I mostly wanted it to camouflage itself using the cuttlefish genes, and I wanted it to be white. We started with Therizinosaurus, the big arms of Therizinosaurus, and I didn't think, since it camouflaged itself so well, and had these big claws on it, I didn't think it needed to really run very fast. But, it's a Jurassic Park movie and things have to run.
Do you have a favorite Jurassic World movie?
Do I have a favorite?
Yeah.
Well, the first one's always best, but I think Jurassic World turned out really well. I did most of my work on Jurassic Park 3, so I got to see most of the aspects of 3, but came out okay too. And I did a cameo on that one, so I guess.
You did a cameo in Jurassic World?
Yeah.
Oh, could you tell us where, so when we see it again, we can look out?
Up on the raptor pen.
Oh,
really?
okay.
Okay. That's really cool.
That is cool. So in Jurassic Park 3, were you really involved because of all the Spinosaurus stuff, or what were you working on in that one?
Well, Joe Johnston was the director, and there was no book for it. So we had to invent the story, and I helped, a lot with the story, and then did a lot of stuff on the set. And then, just worked really close with Joe and the editors and everyone. I just, basically worked on every aspect of the movie except goring of it.
Yeah, it's really neat. You mentioned that you got to work with the animatronics in the first movie. We've seen a lot of stuff on the different animatronics, especially the big T-Rex. It looks like that would have been a lot of fun.
All of the animatronics were really great. In Jurassic Park 3, we had the largest animatronic ever, and that was the Spinosaur animatronic. In Jurassic World, I worked on Jurassic World, but it was almost all electronic because they had no animatronics. When I was working on set with all the other movies, I was on set every time there was an animatronic dinosaur on set. So in Jurassic World, there really aren't any animatronic dinosaurs, although there are. They do use actors for the raptors in the pen.
How did you first become interested in dinosaurs?
I was born this way. I'm pretty sure that's the answer.
That's a good one.
I can relate to that.
Can you talk a little bit about your discovery, the first big discovery at the nesting site?
First off, in 1977, I went back to the place where I found my first dinosaur bone when I was 8 years old. And I found an egg, a dinosaur egg. And that was in the Two Medicine Formation. And then in 1978, when I'd come back out to Montana from Princeton to look for dinosaurs, I was actually looking for eggs and babies, juveniles, and stuff like that. And no one had really done that before. And so I'd gone back to the place I got the egg, and then I was looking for some places that we had found that juvenile dinosaurs had been found. Not babies, but, littler ones. And really didn't find anything. And then went to one of our sites in northern Montana, in the Judith River Formation, and ran into a guy named Bill Clements from Berkeley. And he had just gotten word from the state of Montana that some lady in Bynum, Montana was looking for someone to identify a large dinosaur skeleton that she had found. And so I volunteered to go over and look at it. And so went over there, identified the big dinosaur in her rock shop and some other stuff. And as I was leaving, she said, "Oh, by the way, do you know what these little bones are?" And so I had a look at them, and they were baby dinosaur bones. And I was very excited, told her that they were very important, and I asked if she could show me where they came from. A week later or so, she drove me out to the site, and it was a mound with thousands of baby dinosaur bones covering the surface. And my friend Bob Macklin and I, we excavated the site over the next few days, and we found the remains of 15 3-foot-long, 1 meter long baby duckbill dinosaurs in a bowl-shaped depression. I mean, there was no question it was a nest, and there were 15 babies in it. Just recently, we actually, doing some screening on the original site, found the remains of 2 more. So there were at least 17 babies in the nest. And then just a few months after that, I had a collector out there looking in the same area, and she found a second nest with babies in it. And so that started a yearly expedition to that area, and we found dinosaur eggs and embryos and babies, and a gigantic herd of Maiasaurs, just everything you could ever imagine.
Were the eggs all Maiasaurs, or were there other dinosaurs mixed in as well?
We have found at least 4 species of dinosaur eggs. Maiasaura is one that we find on the Maiasaur nesting ground. We also find Troodon eggs. They're up a little meteor Troodon. We also find eggs of some other meat-eating dinosaur that we haven't found big enough embryos in to identify yet, but we do have skeletons of Sauropelestes out there as well, so could very well be Sauropelestes eggs. And then we also have some small eggs. They might even be bird. We're not sure yet. We just don't know what they are because we don't have any embryos in them at all. So we have 4 species at least.
But they're all in the same bowl, the same nest?
No. No, they're all in different horizons even. We find Troodon nests and potential Sauropelestes eggs all together. Not in the same nest, but in the same nesting ground. And the Maiasaura eggs are only found in the Maiasaura nesting grounds where we found the babies before. And then the little eggs that we find, we just find occasionally, and they're pretty randomly scattered around different areas. The area where we work, the area where all the babies have come from, and all the Troodon eggs and all of this stuff is about 1 square mile. A very small area. It's about 1.5 square kilometers and about 100 meters thick vertically, stratigraphically.
This discovery, since it was pretty early on, did that help you? We saw one of your TED Talks and was like, where did all the baby dinosaurs go? And did that kind of spark an interest in looking for the babies and the younger dinosaurs?
Well, the TED Talk, that was a much later thing. After I found the babies and had a number of juveniles and started finding juvenile skulls, began realizing that the juvenile skulls were, really different than the adults. And so about 15 years ago, I started really sort of concentrating on ontogeny and looking at growth in ontogeny. So looking at how bones grow and relating that to the ontogenetic age of dinosaurs and seeing what was going on with them, and discovered that a lot of dinosaurs that people had named in the past were actually just juveniles of some other animal. And then started sort of tying them all together, looking at formations, looking at Rockies where, say, a couple of different dinosaurs that looked like they were really closely related, and looking at those ontogenetically, looking at their bone structure and seeing if one of them represented a juvenile of the other. And, started finding quite a few things like that.
I know that has led to some controversy, especially with like Torosaurus versus Triceratops. We had at least one person come onto our podcast to talk about that. But what kind of reaction have you gotten from your peers on this?
Well, there are people that think it makes sense, and there are some that think it doesn't make sense. And it's certainly testable. I mean, it is find the Torosaur, and no one has found one yet. We know what the ontogeny of the different features looks like. So basically, we know how the different epiossifications change shape, and so we know that a mature, for instance, one of the little epiossifications on the edge of the frill, we know when there's juvenile or even subadult, and all of the Torosaurs that have been found have the adult morphology of Triceratops. So until someone finds a juvenile or subadult Torosaur, it's still the most parsimonious explanation.
So your current research is on dinosaur growth and behavior. Can you talk about what you've been doing, I guess, recently?
We're still, that really is, we're looking at the different aspects of growth and behavior by using histology to sort of ground truth our hypothesis. So if we think that one taxa might be the juvenile or adult of a different taxon, then, we cut them open and look inside and see if that's the potential. So we're doing that with a lot of different taxa right now. We're even looking at a variety of different ontogenetic sequences of what may be different sauropods. Sauropods are a mess, as anyone knows about sauropods. And every time somebody finds one, they name a new one. So we're trying to at least figure out, the ontogenetic sequences of different parts of sauropods so that, people can at least start evaluating them. But we're doing that with all the dinosaurs. We're just looking at different things that change late in ontogeny. identifying the potential features that change either isometrically or allometrically, and just see if we can sort of figure out the growth sequence of some of these dinosaurs.
Since you brought up sauropods, can I just get your thoughts on the whole Brontosaurus, everything that's gone on with Brontosaurus?
Well, they didn't really present enough evidence to synonymize them, I don't think, but I mean to keep them separate. So, for some reason, people just really like having lots of taxa.
Yeah, because I think a lot of their explanation was, well, it's just as different as other ones that are named differently, but that doesn't really approach the question of should those other ones have been named as different dinosaurs in the first place.
Exactly. Exactly right. And paleontologists should be right now in the business of trying to, minimize them and, really, evaluate them objectively rather than just trying to make new taxa.
You helped discover the T-Rex fossil in 2005 that they ended up calling B-Rex. Could you tell us some things about that discovery and the soft tissue and all that good stuff that came out of it?
Yeah, B-Rex was one of the 5 T-Rexes we found in 2000, and it was discovered by Bob Harmon, my chief preparator, and basically we found, he found a metatarsal sticking out of the hillside, and when we got up there close to it, we saw 3 other bones, vertebrae and rib, but it was under 30 meters of rock, so it required a huge excavation, and we didn't have any access to it. The closest we could get to it was about 1.5 miles by boat. We could get to about 1.5 miles from it by boat, but there were no roads or anything into it, so we had a helicopter and brought everything in and out by helicopter and spent several months excavating the thing. I put 12 of the best excavators I've ever had on the site, and they excavated down to it, and it turned out to have a pretty nice skull, hind legs, and a few vertebrae and a few ribs and some other things, but it wasn't a very complete T-Rex, and it's not a very big T-Rex, but we had one piece that was too big for the helicopter to manage because it had both hind legs in it, and so we had to split the jacket in two, which, we do on occasion. But this time we split it open, and there was some unusual bone material inside the femur, which we shipped off to Mary Schweitzer, one of my former doctoral students, who studies internal structures of bones, and she was able to identify the weird-looking stuff as medullary tissue, which meant that B-Rex was female, a pregnant female. And then when she decalcified the bones, out popped blood vessels and cells, osteocytes, and then later from those structures, she was also able to get the protein collagen and elastin. Turned out to be a pretty good specimen.
In your book, you mentioned that you had some hope that maybe we'd look inside other bones and find similar clues and potentially other soft tissue or, more detail than we previously thought we could get out of bones.
Yeah, we got a lot of stuff, but then we did up and ship it off to North Carolina where Mary was. We thought maybe it was breaking, but some of the material was breaking down in the atmosphere, so we built a laboratory, a clean lab in the back of an 18-wheeler trailer, and actually took the laboratory to the field when we had another specimen to excavate that was in very good condition and also buried pretty deep. It was a duckbill dinosaur, a Brachylophosaurus, in excellent condition. And so we took the lab out there and we took some extractions, and we got much better soft tissues out of it. Protein, originally we were looking for DNA, and in neither case did we ever find DNA. We think it's there. We've stained for DNA and we get positive results, but we haven't been able to find any suggesting that it's pretty tiny fragments. But we think we'll still get one of these days.
Just to bring up the T-Rex that you have found that was larger than Sue, it was found with, 5 other T-Rexes, so they were possibly moving in a pack when they died. Can you talk about that find and what light it sheds on T-Rex behavior?
Well, let me just talk about size on T-Rex. I mean,
Okay.
People are always going to find new, bigger dinosaurs because if you think about it, in any population, it's really hard. If you just go out and randomly collect 10 human beings off the street, downtown on a Saturday afternoon, the chances of getting the oldest one is pretty low. I mean, it's almost zero. And one of the things we know about dinosaurs is that they didn't grow throughout their life. They do have a stopping point, but very few of them actually make it to that point. So most of them are dying before they reach a skeletal maturity. And every T-Rex we've found so far is still growing. So we don't have any T-Rex yet that shows skeletal maturity. And that includes Sue, and it includes the big one that we have as well. So a bigger T-Rex doesn't mean anything, really. Just like a bigger anything. A bigger sauropod doesn't mean anything. And it's just, it's interesting just, from a very general point of view. But if you understand that most dinosaurs are subadults or still growing, it doesn't really mean anything.
So you were talking a little bit about DNA in the fossil finds, and it immediately reminded me of how you say, well, we already have the DNA basically in our modern birds, and your whole Chickenosaurus project, that How to Build a Dinosaur book is based a lot around. What inspired you to start working on that?
We couldn't get any DNA out of the dinosaurs, so. We know birds are dinosaurs, and therefore, we have dinosaurs. But it's always interested me that birds have evolved, they've changed so much from their dinosaurian origins. And even within birds themselves, modern birds are very different than Archaeopteryx. And it's clear that, that the changes that they went through are the potential of the genetics, the genetic pathways being still in the birds is there. So it's the alternative to using DNA to make a dinosaur. If you want to try to bring a dinosaur back, which, it was sort of Michael Crichton's story in Jurassic Park, but you don't have DNA, then you have to come up with a different project. And that was sort of the impetus of the Dino Chicken project. It was, we had Mary Schweitzer and he actually had an NSF grant to try to extract DNA from a dinosaur in '93 when Jurassic Park came out. And of course we weren't able to find it, but I sort of took that on as a project to see if we could come up with a way to make a dinosaur. And retro-engineering a bird seems like a pretty good way to do it. And if you've been keeping up with, some of the things going on, we certainly know that it's possible. We know how to put teeth back in a bird genetically, and we know now how to change the whole face of a bird and bring it back to a dinosaur-looking head. And, we're working on the tail now, and we're discovering that there are a lot of genetic pathways that take out the tail completely in very short, there are some genetic pathways that will take the whole tail out all at once. It's not an evolutionary trend that it could have happened very quickly. And the hands are sort of the same thing. The fusion of the hand to make the wing is another thing that is very, very simple. The genetic pathway seems to be something that could happen very quickly.
Aside from the hand, tail, teeth, beak / snout, is there anything else? I guess maybe there's that toe, is it the hallux that changed? What else would you want to go after next in terms of reverse engineering it?
Well, if you take a bird and we change its mouth and we give it teeth and give it a long tail and give it hands and arms instead of wings, about the only thing left to do is to knock out the sternum, right? That is really all that's left. And once you do that, you have an animal that looks, for all the world, like any little Saurischian dinosaur.
I wonder how tricky the sternum would be. It sounds to me like it would be difficult, but I would have thought making a tail would be difficult too. So.
Yeah, I suspect the sternum will be relatively simple. So you know all about knockout genes, right?
Mm-hmm.
So we knock out some genes and shorten the whole mouse, right? Or we can knock out a couple of there are some Hox genes we can knock out, take out the whole arm, the humerus, the ulna, and the radius, leaving a hand attached to the scapula. The notion of taking out the sternum doesn't seem very complicated when we know that one gene will take out the humerus and the ulna and radius.
So how long do you think it'll take to completely reverse engineer?
There's just no way to predict the time because it's the tooth. Matthew Harris, who worked on the top of chicken to get the teeth, it took him just a few months to figure that out. It took 7 years to figure out the snout beak thing. I have predicted a total of 10 years for the tail, and we're 5 years into it already, and it seems like it's getting closer. So I'm still guessing that it won't be more than 5 more years at the most before we figure the tail out. And the hands, I think somebody else is going to get pretty shortly as well, because there's a couple of labs working on it. So again, it's just a matter of luck. If we knew what the genes were, obviously we would do it, but we have to identify them. And some of them are atavistic genes, some of them are actually, genes that the animal carries, and some of them are genetic pathways that we have to sort of reinvent. It's like the tooth gene. I mean, we can get a first generation tooth to grow in a bird, but it won't have enamel because birds have lost their enamel gene, which means we'll have to add it transgenically. Which is, that's transgenics is fine. It won't be the exact genetic pathways that, it won't be a historical thing. But the idea is to make a dinosaur, then, Indominus Rex should be just as much of dinosaur as anything else, right?
About how many people are working on this?
Well, that's a good question. When I started the project, everybody thought it was just the wackiest idea. And people, when I tried to get postdocs to work on it, there were people that told the postdocs, the potential postdocs, that it would kill their career. I mean, everybody just thought it was the craziest idea. And now we've got, the Taven Lab at Harvard working on it, and, everybody in the country is just trying to get a piece of the action there. There are at least 5 laboratories in North America working on it. But, I think that's probably true with most projects, right? Most projects people think are a little wacky to begin with.
Going into your writing, you've written 8 books so far, but do you plan on writing more in the future?
I've got 2 that are just about finished. One that's really on ontogeny and growth, called Growing Dinosaurs. And then I've got another one that's more about dyslexia and some of the, trying to get kids with dyslexia more interest, more, give them some confidence to get through school so they can get on to the projects in the rest of their life.
Has that affected at all being a paleontologist, being dyslexic as well, or doesn't really?
Well, I think dyslexia helps. Dyslexia is just a different way of thinking, and we dyslexics are very spatial. And studying bones, or studying geology even, it helps if you're spatial. I think it's very useful. I think dyslexics excel in paleontology and geological fields. They're just not very good at reading.
Yeah, some of those words are pretty difficult too.
Yeah, it's just a different way of thinking about stuff.
Do you have a favorite dinosaur?
No, not really. I like Maiasaura because we have so many of them, and I like Achelousaurus because we have so many of those. Any dinosaur I can get a lot of, I like. So if I have their eggs and their embryos and the juveniles and subadults and adults, that's a dinosaur I really like. Obviously, we can do more with them than we can with any other dinosaur.
So what's on your wish list of finds?
I don't know that I have anything on my wish list. I just like to think that I'm open-minded enough that when I go to the field, I won't miss anything.
We have just one last question. What advice would you give to budding paleontologists or dinosaur enthusiasts?
Follow their dreams. That's all there is to it. Just read up all they can on things about dinosaurs and geology and mathematics and, anything useful, but then spend more time thinking about it than reading about it.
Thank you so much for taking the time today to talk with us.
You're very welcome.
So now on to our dinosaur of the day, Maiasaura, whose name means good mother reptile. Maiasaura was a hadrosaur, duck-billed dinosaur that lived in Montana in the late Cretaceous, and the first fossils were found in 1978, and the genus was named in 1979. Marion Brandvold and her son David Trexler found quote-unquote Egg Mountain, as it's known now, which is a nesting site in Montana. Marion found the eggs, and a woman named Lori Trexler found the holotype. She found a Maiasaurus skull, and it was Jack Horner and Robert Macola who described the holotype. The species name is Maiasaurus peeblesaurum, and the name is based on finding these nests with eggs and embryos and young dinosaurs, which was evidence that Maiasaura fed its young in the nest, and it was the first evidence of a dinosaur doing so. Maya was a goddess in Greek mythology, and Jack Horner used the feminine form of the word Saura to emphasize this motherliness. Most dinosaurs, you notice, would have the male-oriented name. It ends in saurus.
Yeah, that is a pretty nice touch. And the first couple times I read it, I thought I might have been looking at a clade or something where, like you have ornithischia, but yeah, it's just the feminine form. That's really cool.
The fossils were found on John and James Peebles Land, so that's why the species type is named after them. And hundreds of Maiasaura fossils have been found, actually over 200 specimens of all ages, which is great for studying this species. Other dinosaurs that lived in the area at the same time included Troodonid, the Hypsilophodont Orodromeus, the dromaeosaurid Bambiraptor, and another hadrosaur named Hippocrosaurus. It's basically a herd of Maiasaurus that was found, and they were all buried under volcanic ash. The herds may have been as large as 10,000 Maiasauras, and because of this, Maiasaura is one of the few dinosaurs where there's solid proof of dinosaurs living in herds. Aside from living in herds, they had some muscular tails, and that was their only way to defend themselves. Because they were such a large herd, they may have migrated seasonally to find more food. Or other theories is that maybe during the year they lived in slightly smaller groups and then they all came together once a year for the nesting. So the area where the eggs were found is now known as Egg Mountain in the Two Medicine Formation in Montana. The nesting site, as I said, is communal. These nests were really close together, kind of similar to what modern seabirds do. There was about 23 feet or 7 meters in between nests, which is about the length of an adult Maiasaura. The eggs were about the size of ostrich eggs, and nests had 30 to 40 eggs in them, and then laid in a circular or spiral pattern. Maiasaura was probably too heavy to sit on its nest, so it incubated its eggs using rotting vegetation. It would put the vegetation in the nest instead of sitting on top, and as the vegetation rotted, it would emit heat. When the eggs hatched, the baby Maiasaura did not have fully developed legs, so probably couldn't walk. We'll get into a little more of that in a minute. They had partly worn teeth, so adults probably brought food to them, at least in the first few months to a year. In 1996, a new study was published that compared newly hatched birds and crocodilians to dinosaur embryos and hatchlings, and that found that the hip bone development was more important than leg bone development. So Maiasaura's non-developed leg bones didn't necessarily indicate a lack of mobility. The study concluded that baby Maiasaura was more precocial or advanced than previously thought and may not have needed as much parental care. But in 2001, Jack Horner studied the growth rates and other developmental differences between Troodon, Orodromeus, and Maiasaura, and found that Troodon and Orodromeus were precocial, while Maiasaura needed a lot more care. Dr. Paul L. Else hypothesized that Maiasaura produced crop milk, which is how some modern birds like pigeons, flamingos, they produce a fatty liquid for their babies. Crop milk would have had antibodies, fat, protein, etc., things needed to help grow. And he wrote an article called Dinosaur Lactation about crop milk based on the relationship between dinosaurs and birds. He claimed that Maiasaura probably produced crop milk because the babies may not have been able to break down plants, and that this fortified milk substance may have been what helped the babies grow quickly. However, one article that kind of talks about this theory and why it might not work is that the way that birds secrete their crop milk is different. So pigeons have this crop organ, but emperor penguins have it come from the lining of their esophagus. And also crocodilians, which are the closest living relatives to dinosaurs other than birds, do not have this ability. So between the two, one crocodilians not being able to do it and birds seeming to have evolved it in different ways, and not all birds can do this, it seems unlikely that Maiasaura could do this. Jack Horner found that there were a bunch of different nests layered on top of one another in Egg Mountain, so Maiasaura probably went to the same site over multiple breeding seasons. Again, like modern seabirds, they might have lived in smaller groups, but then once a year came to these areas to raise their young, and their young grew very rapidly. In the first year, babies grew from 16 inches or 41 centimeters to 58 inches or 147 centimeters, and then they left the nest. And this rapid growth may mean that they were warm-blooded. The babies looked very different from adults. They had larger eyes and a shorter snout, were much cuter, which you see in animals today who need their parents in order to survive when they're young. Juveniles under 4 years walked on 2 legs, but adults walked on 4 legs. Their front legs were much shorter than their hind legs, so possibly when Maiasaura ran, it ran on its back legs and used its tail for balance. In 2001, paleontologist David Dilk said Maiasaura may have changed its postures as it grew older based on muscle scars that showed young Maiasaura ran on 2 legs and walked on 4 legs when it got bigger. Jorge Kubo, Holly Woodward, Owen Wolf, and Jack Horner reported that after cutting open 2 bones, one of a 1-year-old Maiasaura and one of a 4-year-old, they found that the bone growth showed the 1-year-old was similar to bipedal animals, and the 4-year-old was similar to quadrupedal animals. The bones had these rinds of extra bone that quickly grew over its outer surfaces, which showed a response to strain. So these bones actually were of their right fibulas in both cases, and in both cases, these dinosaurs probably broke it, and then the extra bone grew in response to the strain on their tibias. But then what's interesting is how, depending on the age of the animal, it grew a little bit differently. So this leads to speculation on whether or not there are too many different types of named dinosaurs, and whether some of them may actually just be juveniles of others, which we covered a lot in our interview with Jack Horner. An adult Maiasaura was about 30 feet or 9 meters long. It was about 6 to 8 feet or 2 to 2.5 meters tall and weighed 3 to 4 tons. It had a flat beak, a thick nose, and a spiky crest in front of its eyes that males possibly used to fight each other to impress females and attract mates. It had 4 fingers on its hands, and feet had hoof-like claws. It had a toothless beak and cheeks to hold in its food. And an adult Maiasaura probably ate around 200 pounds of food per day, possibly leaves and seeds. Although Maiasaura coprolites from Wyoming show that they also ate lots of wood. As of 1985, Maiasaura is the state fossil of Montana, and this, I wonder if it's because also in 1985, astronaut Lauren Acton went on an 8-day mission called Spacelab 2 and took with him a piece of Maiasaura bone and a Maiasaura eggshell into space. And you can see these now in the Museum of the Rockies in Montana. Maiasaura is in another piece of media. In 2010, there was an animated Japanese film that was based on a book called You Are Yumaso, where a Maiasaura raises a baby T-Rex. Maiasaura is a hadrosaur. It's not the largest hadrosaur. It's most closely related to Brachylophosaurus, which is known as the quote-unquote dinosaur mummy, because in 2000 a subadult named Leonardo was found, and it was a partially mummified skeleton. Maiasaura is a saurolophine hadrosaur because the crest on its snout is solid. And we talked a bit about this in a couple episodes, like episode 31, Corythosaurus. There are 2 subfamilies of hadrosaurs. There's the Lambeosaurines, which have hollow crests, and the Saurolophines with solid crests, or no crests. And until recently, Saurolophines were known as Hadrosaurinae. But then it was found that the genus Hadrosaurus was more primitive, so the subfamily was renamed to Saurolophinae.
And our fun fact of the day, we might have alluded to this one before, I'm not sure, is that fossilization requires specimens to be buried quickly, like in a marsh or quicksand, so we may not ever discover dinosaurs that lived on the tops of mountains or in other conditions that don't lend themselves to fossilization.
And that wraps up this episode of I Know Dino. Thanks for listening, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur at iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.